Hello, my name is Cho. Today's I'm gonna introduce about electronic energy and station semiconductor. Firstly, we are going to look at about history of atom modeling and history of atom modelers from Dalton, and Thomson, Rutherford, and finally we get to Bohr's. We are gonna mainly look at about Bohr's atom model, and it is which means that for the atom to be stable, the electrons could have only certain energy quantities. And Bohr's assumption is electrons can exist certain stage stable energy level. And electron can move from a level to another level, which means orbit to orbit with energy transferred. Electron orbitals have angular momentum proportional to integer and Planck constant divided by 2 pi. Here is angular momentum. And angular momentum is defined by these two things, and we can combine this one to get electron velocity. Or we are going to finally get rid of velocity and calculate the radius of the atom. So here is the velocity. So we can get this equation by this thing came out from Coulomb's law, and this thing comes out from centripetal force. So you can get the radius equation of the radius. There is a electron's velocity, and here is the electron velocity. So we can put it here, and we can get the equation of radius without velocity. Next one is Bohr model for hydrogen atom. A Coulomb force between two particles with charge Q1, Q2 equals this one. This is the minus Q step because electron and nucleons are at different opposite charge. Electrons have negative charge and nucleons have positive charge. Next one, here is the how you can get, here's stuff about potential energy. And you can finally notice that potential energy and is related to radius. As you can see, this is came out from this equation, but this is not. But in real life there is a symmetry, so we can get this values as we can get this value. The next one is periodic structure, and there is a crystalline, polycrystalline, and amorphous. And first one, crystalline is the atoms making up the crystal arranged in a periodic structure. And polycrystalline is a solid composed of many small regions of silver crystal material. And amorphous solid is there's no periodic structure, as you can see in here picture. This is a crystalline, semi-crystalline structure. And as you can see, very periodic. This is polycrystalline. Like, this is crystalline, but this grain is crystalline, and here is the grain boundary. So polycrystalline means poly means many, so there's many kind of crystalline parts. But amorphous is in that. There is no periodic structure in here. Next one is Cuban lattice. There is some solar lattice, but we are going to talk about Cuban lattice. We can get some, there is a three cubic structure. First one is simple cubic structure. The second one is body-centered cubic structure. And last one is face-centered cubic structure. We can call it SV, BCC, FCC. Mm. First, there is a number of atoms per unit cell. A simple structure has only one, but BCC have two, FCC have four. Well, you can, as you can see, here is the 1 divided by 8, one pieces. that so there is a piece of this, so there is one. And here is a piece plus one atom, so two. And here is one, two, three, four, that's it. Divided by two equal three. Three plus one is four. So here is one, two, four. Next one is a coordination number, which means a number of closest neighbors or bounded atom. You can think about this by some geometrical stuff in your brain. So, like this one. Here is one atom and eight atoms are labeled atom B. So, yeah, 6, 8, correct. You can like this, think about this by your own. Next one is atomic picking factor. Factor means sum of atomic volume divided by the cell volume. You can easily understand about this by when you put up balls in the box. Um, this means percentage of okay. Next one is some example about some of these things and how to get accurate. Next one is diamond cube, which means diamond lattice also can check by diamond lattice and use FCC lattice with a basis of two atoms. Collect this one. The next one is Miller indices. There is plane. Some stuff like a round bracket, a square bracket, polar bracket, braces, and angle bracket. First, round bracket is a surface, and box square bracket, whatever you want. You can say box bracket or square bracket. Like it means a vector. It's like a direction. Direction. So here is some example. You can write 001 with a round bracket and plane. But you may not. So 010, 100 with one bracket means a surface. So also 110 with one bracket means when you have this one, you'll scale that is, and yeah, as you can see here, 110 surface. The next one is, as I said before, this one is vector. So 101 vector is this one x, y, z. So x and z. So this is 10. I'm not told that this 001 plane or stuff or surface is 001 is z is here 1. But this is normal vector and surface is orthogonal, so surface is here. We can say this stuff round bracket. Um, let me introduce by the structure. This structure has surface, if the x, y, z is here, this is x, this is symmetric structure. So here is the 0, 0, 0, 1, but you can see from here, x is here, and, and you can rotate here, but same, but is 1, 0, 0. And another one is 0, 1, 0. So, in this case, you can use let's see, curly bracket. So 100 with curly bracket means 100, 010, 010, 001 with round bracket. Also, it can be used in vector. So one with square bracket, 100, 010, 001 with square bracket can also use as an angle bracket like this one. So this means these all three. And we had done some example about these Miller indices, periodic structure, sort of. And this is end of today's video. Well, thank you for watching my video.